Okay, let's look at this example where I have to find the integral of the square root of 9 minus 4x squared. Of course, this comes from trigonometric substitution. Okay, so this is still in the form a squared minus x squared, of course, square root there. So meaning we're going to let our x be equals to a sine theta. Okay, but before I do that, I would want to leave the coefficient of x squared here to be 1. So how do I do it? Okay, so I'm going to factor out the 4, or just force the 4 out. I'm going to have my 4 here, then 9 over 4 minus x squared here, then I have the x. So here I'm going to have my square root of 4, meaning it becomes a 2 here. So what I'm remaining with is 9 over 4. Okay, 9 over 4, in fact square root of 9 over 4 minus x squared dx there. Okay, so meaning our x is equals to, our a in this case is a um, square root of 9 over 4, of which we are saying our a squared is equals to 9 over 4. So meaning our a is equals to 3 over 2. So this is going to become 3 over 2 sine what? Sine theta there. So we have our 2 here. Okay, then this is 9 over 4 minus, where there's x here, replace with what we have here, and what you're going to end up having is 9 over 2 sine squared theta. Okay, so again, where there's dx here, remember to say in this case our dx will be equals to 3 over 2 cos theta d theta. Okay, so this will be 3 over 2 cos theta d theta. So what we have here, this is similar to the other examples that we have done. Okay, this is similar to the other examples that we have worked on. So at this point, I can say I have my 2 here, then I can factor out, in fact this is 4, sorry, not 2, that's a 4. So we can factor out the 9 over 4, then we have a 1 minus sine squared theta here. Okay, we have 3 over 2 cos theta, we have d theta there. Okay, so here what I have is I'm having something like 9 over square root of 9 over 4, which is simply 3 over 2, and this simply becomes a 3 here. Okay, because I have a 2 outside, then 3 over 2, meaning this 2 goes and that 2 goes, meaning I remain with a 3. Okay, we remain with a 3 right there. So what follows here? What remains is that I have the square root of 1 minus sine squared theta, which is simply the square root of cos squared theta, which is cos theta. So I have I'm going to have cos theta here. Okay, cos theta multiplying by another cos theta. Let me just write it as cos squared theta here. Then I have this 3 here, 3 over 2 multiplying by the 3 outside. So what we are going to have is that this will become a 9. Okay, to save time, this will become a 9 over the 2 there. Become a 9 over 2. Then we have the theta. Okay, so this is still, as I say, this is still similar to the one that we worked on. This one just required us to do some like putting it in the desired order that we are familiar to work with. So this is 9 over 2. Okay, so cos squared theta, remember to say we said this is equals to cos 2 theta plus 1 divided by 2. Okay, you have the theta there. So this is 9 over, I'll say 9 over 4 then I'm having cos 2 theta plus 1 there, d theta. Alright, so now we know what the integral of cos 2 theta is. The integral of cos 2 theta is simply 1 over 2 um, sine 2 theta plus the theta from this one here, and that's what we are looking for. But we don't have to leave it like that. We can try to express the theta there in terms of x. Okay, so we know that our x is equals to a sine theta, so meaning our theta is equals to sine inverse of x over a. Okay, sine inverse of x over a. So meaning here what you're going to have is 9 over I'll say 9 over 4 multiplying by 1 over 2. I'll say sine, open bracket, 2, the theta is sine inverse, or let me just use arcsine. I say arcsine of x over a, okay, plus my theta again is arcsine x over a, like that. Okay, and that is simply the integral that we are looking for. But if you want, you can distribute the 9 over 4, which is outside, then this will become 9 over 8 sine sine 2 arcsine x over a. Okay, we're going to have x over a there, x over a, then plus 9 over 4, we have arcsine x over a. But remember to say our a. Okay, we have said our a is equals to, in fact I was just supposed to replace back then, but yeah, we're going to have our 9 over 8 sine, then you have our 2 arcsine, then here we're going to say our x divided by our a. Our a is 3 over 2, okay, of which this becomes 2x over 3. Okay, so you can use what, 2x over 3 there, plus 9 over 4 arcsine 2x over 3 here, and this is simply the integral that we are looking for. So I guess I was supposed to just replace here direct, but I was supposed to use this one. In fact, I was supposed to say theta is equals to sine inverse of 2x over 3. Okay, so and this is what we end up with as our integral, and that's how you go about it.